I'll say welcome, everybody. My name's John Mayer. I'm the director of the Amesbury Carriage Museum. I welcome you to our first Tuesday program. We are delighted tonight to welcome a guest speaker, Tom Kelleher, who's the curator of mechanical arts from Old Sturbridge Village. And Tom will talk about the nature of early industries in a New England village. We talked a little bit about the interplay between, people who worked on farms and the different types of mills that were active. But I think what we'll hear from Tom is a perspective about how that's interpreted in Old Sturbridge Village. You've been
Hey.
there since 1984, Tom?
Yeah, heaven help me. I was hired as one of the strong young men to run our then new sawmill.
That's amazing. Yeah. So it's a treat to have you here tonight. A little bit of business for everybody. We are pleased to acknowledge our sponsors for 2021, Ed Selden and Lisa Witham, the Amesbury Chair Company, Amesbury Industrial Supply, BB Alarms, and Sacris Design and Jennifer Sanborn are our annual sponsors. And then we have program sponsors, Wayne Barbaro, Mike Harold and Leah Cabine, Peter and Patty Hoyt, and Tom Pendergast. But I wanted to say June 1st will be our next first Tuesday. And on June 1st, we'll have a presentation by Bob Casey, who is the former John and Horace Dodge Curator of Transportation at the Henry Ford Museum. Bob and I were both Hagley Fellows, and I was delighted when I reached out to Bob that he was willing to be on the program. His topic is, he's calling From Horses to Horsepower, Adopting the Automobile in America. And June, if people from Amesbury know, is the car show month. We probably will not have a car show in June, but we want to spotlight some of the history about automobile body making that happened in Amesbury. So on June 1st, Bob Casey will kick us off with a program. And basically what Bob's going to do is explore how carriage making evolved into the production of automobile bodies, or automobiles, actually. And Bob had a great saying. He said that innovation is the mother of necessity, saying that people who were making cars were really just exploring this wonderful technology, and they had no clue what to do with it. So there were a lot of people making very curious and interesting, mechanical things. Carriages remained an important mode of transportation. So Bob will be a fun presenter. Well, with no further ado, we have Tom Kelleher here. Thank you, Tom, Curator of Mechanical Arts from Old Sturbridge Village. I'm thrilled to have you with us tonight, and you're going to share some stories about the early industries of a New England mill village.
Yeah, thanks for having me.
Yeah.
So I'm going to start about talking about the fact that for a couple thousand years, mills were not industrial, but pre-industrial. In other words, they were service-oriented industries, much like a dry cleaners. Here at Old Sturbridge Village, we have 4 mills, 3 water-powered and 1 horse-powered, a grist mill for grinding grain, a sawmill for cutting lumber, a carding mill for untangling wool fibers, and a cider mill. I've long joked that the cider mill is my favorite because I'm not directly in charge of it. It only operates for a month a year, and it makes alcohol. So that's one reason that's my favorite. But anyway, the whole idea of mills, of course, is it replaced hand processes, not only in the ancient world, but today. You can see the Egyptian above using a saddle stone up on the right for grinding grain, and the mortar and pestle, the 2 primary hand processes in grinding grain, which was the first hand process mechanized for in mills in the ancient world. And a number of those old mills survive today, originally powered by people, either by women or enslaved people, and then they adapted it to animal power, and a lot of the world is still using animal power for that. Of course, up until fairly recently, in the grand scheme of humanity, muscle was the primary source of power for most work, whether it be human muscle or animal muscle. But a couple thousand years ago, water power became increasingly used for doing work, especially for grinding grain. I have a picture on the screen of Marcus Vitruvius Pollio, who somewhere around 23 BC published a book called 10 Treatises on Architecture. And he didn't invent mills, but he kind of described a water-powered grain mill, kind of the way you or I might describe a bicycle to someone who hasn't seen one. Not like I've invented this clever thing, but rather, if you haven't seen a bicycle, let me tell you how it works. And that's what he did with water-powered mills. And the ancient Romans had a number of water-powered mills, although, of course, the ancient world was still a world where muscle was the primary power for doing things. About 20 years ago, I had the good fortune to spend a month in Romania, in Eastern Europe. And in Western Romania, not far from the city of Timișoara, there's a little village called Rudaria on Rudaria River. The communists renamed it Eftimi Mirgu. But nonetheless, it had one time had probably about 100 little tiny water-powered mills. I think 22 still remain there. But they're cute little things, probably about like 10 by 10, 8 by 10, tiny little things. They're actually owned by family groups, clans, that get a 12-hour shift every month to for each household to use the mill to grind their grain. And they're very simple water-powered mills for grinding the grain for each family member, with a very simple water wheel, direct drive, no gearing. Of course, sawing lumber was something people had long done, like grinding grain by hand, that they adapted water power to. Various textile processes as well, carding, spinning, weaving. But before you can do anything with water power, you have to be able to get a control of it. There's very, very, very few places on the earth where you can just plunk a mill down and expect it to run efficiently. So most of the time, you have to modify the landscape. And the biggest modification is usually building a dam. A lot of times where we see dams, or excuse me, we see what looks like potential water power in New England, what we're seeing is the remains of a place where someone has already built a dam. Often the dams were made out of wood, which after a few decades, much less a few centuries, those dams don't survive, but the water power is there. Sometimes they're, of course, stacked logs, but sometimes they're just boards, as you can see on the upper right and the lower right. And those things don't survive forever, but like most things, it's a matter of the human perspective. I remember a couple of years ago, I was building a roof here, or replacing a roof at a building here at Old Sturbridge Village with wooden shingles. And I was in historic costume. Somebody asked me, how long is this roof going to last? And I said, this roof is going to last forever. And they laughed and said, no, really, how long is it going to last? I said, this roof is going to last forever. And they laughed again. And they said, no, really. And I said, look, I'm 62 years old. I'm not going to be on this ladder in 30 years replacing this roof. As far as I'm concerned, this is a forever roof. And that's how way these people saw a lot of these mills and these dams from their own human perspective. A lot of the mills were expected to last for 5, 10, 15 years. And very often they would saw the lumber in that area, and then it wasn't worth worrying about them. I mean, certainly grain mills often were more long-lived than that, but very often people had a very human perspective for the life they gave to their dams, their mills, their machinery. I'm not going to dwell on dam construction. There's a number of ways to do it, with logs and stone, combinations of that, rammed earth and other things to basically control the water. The whole idea, of course, with water power is its gravity, and the more water you can get to go through a mill and the farther it can drop, the more power you have. And of course, all this work had to be done with hand power. There were no machines to move the stone around, but people, of course, had simple machines like cranes, ramps to move stone and earth into position, to create the dams, to raise what's called the head, the distance the water falls, and to control the water. and also protect the dam itself by having spillways, sort of safety valves, to let the water that you're not using escape safely without it going around the dam and undercutting the soft earth and undermining the dam. And of course, not just rivers, but on coasts, tide mills were very common, where you could take advantage of the force of the moon, causing by harnessing the water that the rising and falling of the tides, using wicket gates and such to control the fall of water through that. The problem with tide mills, of course, is you can only run twice every 12 hours for a few hours in that group. And of course, it varies about an hour a day when the tides are. So you end up with an odd schedule for operating your mill when you're running a tide mill. But basically, what you have is what are called wicket gates that let a one-way valve that lets the water in when the tide rises, and then when the tide starts to fall, those gates close and hold the water back until the tide has gone out enough that you've got a difference between the headwater and the tailwater, the upstream and the downstream, as it were, on a river, and you can let the water through your mill and do your operation there. And there were at one time hundreds and hundreds of tide mills up and down the American coastline. Just a few other terminologies. Your intake, if you will, your upstream is your head race, and your exhaust pipe, if you will, is the tail race between the water wheel. And you need to have a head race to control water going into the mill, to deliver water to your wheel, no matter what type of wheel you have. And there's a number of different ways you can do that, by channeling through the earth, lining with stone, having a sheet metal pipe, having a wooden flume, all sorts of different ways to control the water going in. And you, of course, you also need a gate, a valve, an on and off switch to control the flow of water. Something a lot of people don't really think about. But water power is just gravity, and it's a very simple equation. Flow, the volume of water going through your wheel, and head, the distance the water falls from the head race to the tail race. The product of those two forces is the water power itself. There's a number of different kind of wheels that have been used over the centuries. The basic vertical water wheel that had been used for thousands of years was the undershot. And then in the Middle Ages, they came up with other variations, the overshot, the breast shot, and the pitchback, which, unlike the undershot, allow more of the circumference of the wheel to actually do work. So it becomes a more efficient way of harnessing the potential energy in the water. It's a slightly more complicated wheel and has other drawbacks, which we need not go into the details of them. But those are the basic kind of wheels. And of course, the names sort of talked about how they work. The undershot is basically just like a paddle on the back of an old Mississippi riverboat, and the water flowing through hits the paddles, and like a kid blowing on a pinwheel, turns it around. It's what Marcus Vitruvius described in his 10 treatises on architecture in 23 BC, and is still used in a lot of applications for generating power. And one of the ways you can use an undershot wheel was called a river mill. Basically, you put a mill on a boat and have it stationary in a river. In medieval Paris, there were a number of these river mills tied to bridges and abutments along the Seine. And these are still used in Eastern Europe here and there to do work, and to just secure the mill, as it were, in a stationary area of the river. And as the river current flows by, it turns the water wheel that turns the machinery in the mill. Putting the water over the top of the wheel is more efficient because it uses more of the circumference of the wheel and more of the potential energy of the water. The problem is you've got to get enough water to go over the top of the mill, and that usually over the top of the wheel. And that involves, of course, building a dam and a lot of more engineering of landscape, which is, of course, a very laborious task. The other problem is, because of the direction the wheel flows, you also have to have good drainage downstream. Otherwise, the mill tries to take the water and push it back upstream with the wheel turns, and that doesn't work. So an overshot wheel is very efficient, but it's very fussy in terms of the topography in which it will work. But they were widely used because they were so efficient. The pitchback, where the water is delivered just before the top of the wheel, and it turns the opposite direction, so the bottom of the wheel kind of pushes the water away from the bottom of the wheel, is a little more dependable and almost as efficient. So it's a good compromise. But the real best compromise over most topographic conditions for these pre-industrial mills is the breast wheel, where the water strikes the wheel somewhere near the midpoint, just above, just below, or at the midpoint, and it's a good compromise of the efficiency of an overshot wheel and the more wide-ranging functionality of an undershot wheel. And you can see here this little animation of the breast wheel taking advantage of the falling water and holding the water in buckets. So with a breast wheel, unlike the undershot where it's the impact of the water, it's actually the dead weight of the water more than anything else that's pulling the wheel around. Basically what you're doing is putting weight on the end of a lever, and a wheel is just really a continuous lever. And that's how these type of traditional water wheels works. This is a shot of our grist mill at Old Sturbridge Village before I convinced them that we really should have a roof over the water wheel. Our grist mill was built in 1938, according to what somebody thought an oldie-timey, folksy, quaincy grist mill should look like, not realizing that in this climate, you really need to have a wheelhouse, a covering for your wheel to protect it from the elements. But of course, since this was built in 1938, they wanted to look picturesque more than look efficient. But historical research has gone forward, so I've got a roof over the wheel now, although not a fully enclosed wheelhouse. But so it's kind of a compromise between letting people see the water wheel and having it protected from the elements. But regardless, the Norris Wheel, as it's called, predates the Vikings. It's basically just a impact wheel. Just blades that the water hits and spins around. It's very efficient for things like grist mills. Those Romanian mills in Ruderia were on this setup where you don't really need gears or anything. You just put your millstone on top of a axle and your water wheel on the bottom of an axle, and away you go. So it's a very efficient kind of water wheel that's been used for centuries and centuries as a way to harness water power all over the world. And a variation of it is to put the walls of a wooden tub around it to keep the water from just splashing off the wheel paddles as it hits, but keep enclosed so that it keeps pushing the wheel around. And that's a lot more efficient operation, the tub wheel. We have a tub wheel in our carding mill here at Old Sturbridge Village. And of course, in 1824, a number of French engineers started evolving a turbine where you have a spiraling of the water to drive the wheel. And there's almost an infinite number of variations of turbines that people have come up with over the past couple hundred years to take advantage of water. The thing about a turbine is that it's not only it's a very efficient wheel, I guess is the point I want to make here, is that it uses a lot more of the potential energy of the water without letting it escape, because it's more of an enclosed system rather than an open system. So you don't have really much splash. The thing about water is if you see it moving, you're seeing energy go to waste. So a turbine is much more efficient. Nowadays, turbines can approach 90% efficiency, which is a lot better than internal combustion engines for that matter. So here's some old turbines. We don't need to get into the details of turbine technology, but there are a number of different, these are just half a dozen variations of turbine designs. And there's dozens and dozens more that people have used and continue to use to generate power. A lot of turbines are used now, of course, to generate electricity. And of course, since a turbine that you put energy into is a pump, they use water power actually to store energy generated by nuclear power in places like Northfield, Massachusetts, Glennon built Gilboa in New York State. They basically have dug artificial ponds at the top of a mountain and then use nuclear generate electricity to run turbines as pumps in the evening when people aren't using as much power, as we've all gone home from work and gone to bed, to pump water uphill. And then when people want electricity, they let the water flow downhill through the turbine and then generate electricity with the water power. So actually water power is a good way until they get better battery technology to actually take advantage of the electrical energy generated by nuclear reactors, which of course are not easily turned on and turned off very quickly. So water power is still very much with us in the nuclear age. This is just a few pictures of our sawmill at Old Sturbridge Village, which has what I call a proto turbine. It's called an outward flow reaction wheel. It's not a fully pressurized system like a true turbine, but more like an open wheel that water fills and the water squirts out of jets on the rim and spins around. Basically what a lot of the Americans were fooling around with in the 1820s and 30s when the French were working on the true turbine. So I think of it as the Australopithecus of water wheels, kind of an evolutionary dead end that was interesting for a while, but didn't really survive. But here at Old Sturbridge Village, where we demonstrate the technology of the 1830s, this kind of water wheel was widely used. Our wheel at our sawmill, the one you can see in the upper right, was actually patented in 1830 by a man from Maine named Calvin Wing. So we have a Calvin Wing outward flow reaction wheel at our sawmill, and he and his people who bought his patent rights made over 1,000 of these. So it fit our mill here at Old Sturbridge Village. Anyway, there's a lot of different ways you can transmit the power at these pre-industrial and early industrial mills. A lot were direct drive, like the mills I showed you in Ruderia in Romania. The Norris mill, a lot of times you just have the same shaft with your millstones on one end, the water wheel on the other, and away you go. Or the sawmill on the right, where you just have the water wheel and a direct drive, a crank that pushes your saw up and down. And then, of course, eventually gears come along. I shouldn't even say eventually. I mean, back in 23 BC, Marcus Vitruvius described what translates out of the Latin as toothed wheels. And that's pretty much how I describe a gear. And by having large gears turn small gears, you increase the speed of rotation. By having small gears drives large gears, you increase the power and decrease the speed. Just like when you're riding a bicycle, big gears driving little gears speed things up. Little gears driving big gears slow things down to give you more power. So simple mathematical equations. And sometimes these mills get kind of bewilderingly complicated to the uninitiated with a mix of gears, which of course in the early years were wooden. Cast iron becomes increasingly common in the 18th and 19th centuries. If you've never heard cast iron gears, they're blessed loud. They're ridiculously loud. One of the innovations of the early 19th century was called the Mortis Gear, where they'd make a cast iron body for a gear, but just insert wooden teeth in one of them, which quieted things down considerably, and also was a sort of a fail-safe, because if anything hung up, cast iron is very brittle material and it's not easily repaired with 19th century technology. So having inserted wooden teeth was something that not only was quieter, but much more easily repaired should things jam up and break. Anyway, and belt drive was another thing that was more forgiving because belts slip, unlike gears. So belts are not a great way to power something precise like a clock, but for anything else, belts are much easier. Belts and drums are much easier to build and maintain than toothed gears. And of course, in the late 19th, early 20th century, machine shops and a whole lot of other factories had literally hundreds of pulleys and overhead belts, which were, of course, wonderfully dangerous for the operator, because you could very easily get your clothing, your hair stuck in these belts and find yourself tangled up in the ceiling before you lost consciousness and bled to death. So that's why belt drive has largely gone away. But at one time, it was very widely used. The other nice thing about belt drive, like gear drive, by going to different size pulleys, you can change speeds, like different gears on a bicycle or an automobile or a motorcycle, different ratios of one size to another, and having two pulleys next to each other, like down below, one attached to the drive shaft and one just spins freely. That's loose, you could turn things on and off without a complicated clutching mechanism, just sliding the belt back and forth from a fast to a loose pulley. That's where the phrase running fast and loose comes from, by slipping the belt from a pulley fixed fast to the machine shaft and one just running loosely. And anyway, so that's one of the advantages of belt drive. And for longer distances, people would use rope drive, which strikes me as a wonderfully cumbersome way of transmitting power, but I guess if that's what you have, that's what you have. And it was used over distances. Anyway, so people had a number of different types of mills, especially in pre-industrial times. The grist mill being the first, that's what Marcus Vitruvius described, grain being the sustainer of life, bread the staff of life, reducing grain to meal, which then can be sifted for flour to make bread, was universally used. Mills are much more rapid and efficient and precise in processing grain as opposed to hand processes. So since the first century BC with water power and about 500 BC for animal and human power, mills were preferable, where you had the technology for processing grain for human consumption. The whole idea of the stones is you put grooves in them, and they kind of work like rotary scissors to shear apart the grain kernels that get fed between them through the eye, the hole in the center of the top stone, the runner stone, the one that spins above the other, and with a water wheel, and usually a larger gear driving smaller gears to make the stones spin faster than the water wheel. We need not go into all these names here. And how millstones work, and also using the power to put in what are called machines for dressing. The bolters, they're called, basically tubes covered with fine mesh to sort out. And here's Vanna in Canada here showing off the bolter at a mill in Ontario. But basically for sifting the ground meal into various grades of flour, removing the bran, the fibrous outer shell of the grain. One of the big innovations in grain milling was developed in the 1790s by Oliver Evans of Delaware. He received the third patent from the U.S. Patent Office for an automated grain mill. I think a number of years ago, they actually put him on a stamp, a U.S. postage stamp. There's a story, probably apocryphal, but it's a wonderful story about someone had heard about Oliver White's automated flour mill, and he went to go see it. And he went to the mill, and the mill was running, and he went upstairs and downstairs and all through the mill and saw everything working, but he couldn't find anyone. So he went outside, and there was a man plowing, and he yelled to the man, "Excuse me, can you tell me where I can find Mr. Evans?" And Oliver Evans said, "Yep, that's me. What do you want?" And it's like I said, it's probably an apocryphal story, but he did invent a mill that didn't really need direct human intervention at every turn, like things had gone before. So historians of technology point this out as like one of the first examples of automation, having a mill that could do all the steps in turning grain into flour, including packing it, all without direct human intervention. And in 1795, Oliver Evans and another man named Thomas Ellicott published a book called The Young Millwright Miller's Guide, which went through 13 printings in the 18th and the 19th century and has been reprinted a couple times, actually, in the late 20th century for those of us that like old mill stuff. But of course, sawing logs into lumber was another thing that people used water power for, taking the up and down of a man standing on a log and a man standing under a log, pulling a saw between them, and using a crank to pull saws up and down to turn logs into lumber was something that seems to have come along in the 1200s. So sometimes at Old Sturbridge Village, when we're demonstrating our sawmill, people ask me, when did they invent this? And I said about 200 years before they came up with buttons and buttonholes, which always amazes people. Anyway, I bring up Moses Marcy of Sturbridge, Massachusetts. Moses Marcy was one of the early settlers of Sturbridge in the 1730s, and he built a sawmill on the Quinnebog River, which runs through our town here in Sturbridge. And sawmills are often the first mills that people built in new settlements because they're the parents of other buildings. And the town of Sturbridge offered Marcy 50 acres of land if by the following September he added a grist mill to his mill site. Your big investment in building mills is not usually the mill itself, but developing the water power, damming the river, channeling the river, getting the power out of it. And so that's what Marcy did. He added a grist mill to his site at his own risk, at his own expense, and his own profit. And the town paid him that 50 acres of land for doing that. The picture of Marcy here on the right is actually an overmantel painting from his house that is in our collection here at Old Sturbridge Village. Of course, when you have your picture painted, you can tell the artist to depict you any way you want with his punch bowl and his pipe and his sash, because he was in the French and Indian War and took great pride in that. But anyway, sawmills are basically just like cutting wood by hand, except you have a crank and a water wheel to do the work for you. Actually, here at Old Sturbridge Village, the reason Old Sturbridge Village is where it is because the Quinnebog River flows through it. And our founder, Albert Wells, back in 1936, realized he could move barns and houses and blacksmith shops anywhere, but to have water-powered mills, he needed water power. And he knew that there had been mills on this property developed by a man named David White. And this picture from the 1890s is of David White's grist mill on the left and David White's sawmill on the right, which were gone by 1936 when the museum bought the property. But the river was still here and the dam was still here. And taking advantage of the water power that had been developed in the 1800s to run these mills is why Old Sturbridge Village is here. Actually, when they first founded the place, they called it Old Quinnebog Village for 10 years after the river, not after the town. Problem is, there's a village in Connecticut called Quinnebog, and people kept showing up there looking for the museum. It got all ticked off that they couldn't find it. So we changed the name to keep people from getting grumpy. And of course, eventually saws became round and took advantage of continuous cutting. Anyhow, another process of water power that was used was carding, taking the old hand cards, the boards with little brushes on them, and making the brushes round, which had been developed in the 1770s to untangle wool. But again, it was a service business. Neighbors would bring in grain to a grist mill, logs to a sawmill, and wool to a carding mill and pay to have it untangled so they could do the other steps by hand. And other textile mills that I wish I had, but I don't, is a fulling mill where you basically take woven cloth and get it wet and pound the dickens out of it to get it to shrink and full, get the fibers to shrink together and become less of a web of threads and more of a mass of felted fibers, much like a pool table cover. The fellow who owned the site at Old Sturbridge Village was a man named David White. His younger brother was this fellow, Alpheus White. And just upstream from where Old Sturbridge Village is, Alpheus White also had property on the river, but he couldn't dam it up. His land was too flat for that. So what he did is he paid people to dig a canal parallel to the river for about half a mile to get the river where it ran over rapids, to wait until it was at the end of the canal and then drop all at once, to drive eventually a sawmill, a grist mill, and what he called a clothier's works, where he carded wool, fulled wool, wool cloth, and even dyed wool. And even for a while tried to experiment in making cloth. It didn't work out. But in the 1790s, when he paid men to dig this canal, back then it was considered normal to expect to have hard liquor as an incentive to labor. And so he sent rum out to his workers, but he sent cheap New England rum to them, and they were not happy with it. So they sent it back and said, we're not going to work until you give us better liquor. We want brandy like we know you drink. And he sent the cheap rum back to him and said, get back to work. And they stopped their shovels until he ponied up the good quality brandy that he drank to get him to work. But fulling mills, which he had, were just basically powered mallets to beat the heck out of cloth to get it to shrink like a pool table cover, is, of course, not looking like thread. Alpheus White's mill village, which was called White's Mills for a number of years, in 1841 was bought by a man from Pawtucket, Rhode Island named Melville Snell, who with partners started manufacturing augers for drilling holes in wood. And for over 100 years, the Quinnebog, just upstream from Old Sturbridge Village at Alpheus White's mill site, was used to manufacture augers for drilling holes in wood. There are some of the Snell augers. One of the great claims to fame of Snell Auger Works, which is now out of business, is that they were used exclusively to repair the USS Constitution during its 1920s overhaul, the one where children all over the country, of course, contributed their dimes and pennies to get the ship built, so rebuilt. So anyway. And of course, blacksmithing is another thing that you'd find in every neighborhood, and water power could do that as well, because while the blacksmith could swing a 2 or 3 pound hammer, a water wheel could lift and let fall a 50, 100, 500 pound hammer and never get tired. And these what are called trip hammer mills, because your water wheel would have a cam on it that would raise the hammer and then just let it fall when the cam passed by, could do a lot more shaping of metal more efficiently than somebody working by hand. Of course, blacksmiths today still use hydraulic trip hammers to shape their wool. One thing about these mills, whether it's a service mill or early industrial mill, is early New England was a very cash poor society. And so people basically, what they called bartered, but they didn't swap. They used money as the common denominator, the common language of business. So goods, services, people's time was all converted to dollars and cents. And since they didn't have computers, they used paper. New England being the most educated place on the planet, perhaps rivaled by lowland Scotland and southern Scandinavia. People could pretty much all read, write, do basic arithmetic. To translate everything into dollars and cents terms and compare literally apples and oranges that way in a day books and account books. And of course, eventually mills took off and got much more industrial as the late 18th and early 19th century took hold. And a lot of these early sawmills and grist mills, the water power sites were taken over by people who wanted to manufacture. Here in Sturbridge, and I'll finish with this story and then we can go to questions since I think my time is just about up, was a place on a body of water that to this day is called Pistol Pond, because Enoch Gibbs and Lucian Tiffany, 2 men in their 20s here in Sturbridge in the 1830s, started making these unique pistols, sort of stealing a patent from a man named Aidan Ruggles, who passed away. Aidan and his brother Fortis Ruggles started manufacturing these underhammer pistols, which only have a few moving parts. They were easy and cheap to make and wildly popular for self-defense in the early 1800s. Actually, both Aidan and Fortis Ruggles died of their own firearms. Aidan Ruggles was out shooting one day in November, stopped in a tavern to warm up, put his gun on a table, and the tavern keeper's son picked it up, thought it was a toy, and accidentally shot Mr. Ruggles. And Fortis Ruggles, when he was over his grief and over the financial disruption of it, set up a shop in a different town making the guns. And he told his workers, when you're done, load it and shoot it out the window at a tree that I've got a target on. If it works, then clean it, pack it, ship it. And someone was testing the gun when Mr. Ruggles came around the corner and caught the bullet in his head. So
Mm.
That was sad, but with them dead and the wives not in a position to defend their patent rights, a number of manufacturers, including Gibbs and Tiffany here in Sturbridge, started making these guns. And even though they were only in business for a few years and only 1 year using water power in a place called Pistol Pond, that body of water is still in 2021 called Pistol Pond. Not that it looks like a gun from the air, but because in 1837 it powered a pistol factory, employing 36 men making these under hammer single shot percussion pistols. But anyway, I'll leave it there. I have lots more slides I could go on, but I'm gonna pause and we can talk about water power and mills and industry if anybody would like to.
Tom, thank you.
Sure.
It's fun hearing your story. We have looked at some of these same technologies in Amesbury.
I'm sure.
Yeah, but we're not blessed by having an actual water-powered mill that we can take our visitors to. So we go to the site and we can imagine it, but it's great seeing the pictures of it. I guess one thing I was curious about, as you're building the story of the mills, how do you learn about the families? You know, where does that information come from that you use in your interpretation?
That's a great question. It like any history, it's a combination of sources. We have the business records because it was a cash poor society. People did write down who owed whose for what, and a lot of the business records of these people survive, and so we can tease out a lot of information from that. There are a number of industrial censuses that were taken. The federal government commissioned a Census of Industry in 1832 under Secretary of the Treasury Lewis McLean. The Commonwealth of Massachusetts commissioned industrial surveys in 1836, 1855, 1845. So we have those things, and we also have town histories that we draw on.
Right.
And there was a group in the 1890s, kind of an amateur historians club called the Quinnebog Historical Society, that presented papers, and they published leaflets
Oh, wow.
with that history. So the story of Alpheus White and the cheap rum and the good brandy that his workers wanted
Mhm.
while he dug his canal actually comes from that source.
That's great. We did get a question from Teresa Giard. She wanted to know what kind of mill was located in Wells State Park near Sturbridge.
Um,
You know?
I'm not sure that I off the top of my head, I'm not sure if there were mills on Wells State Park. Walker Pond is the body of water there, and of course our founders, the Wells family, Albert Wells and his siblings and descendants, owned a lot of the land there. The pond is called Walker Pond because it was owned by a family named Walker. Perez Walker was one of the scions of that family. The father-in-law of Cromwell Board, who owned the principal tavern in early 19th century Sturbridge at the time. Off the top of my head, I'm not sure. If there was a mill there, I'm almost sure it was a sawmill. Sawmills are the most common kind of mills. In 1830, for example, just the town of Sturbridge had 13 sawmills. Not that it's a great lumber capital, but between the Quinnebog River and the tributary streams, there's a lot of water power potential, and logs are heavy. They're not worth a lot per pound. And so sawmills tended to serve fairly limited geographic neighborhoods.
I liked your interpretation about the mills being service.
Yeah,
which,
thank you.
Which is a nice way to think about some of the distinctive mills that we've learned about in Amesbury. We had in 1796 a nail factory that was developed by Jacob Perkins. So, and what I would think with a mill like that, that was more of industrial reaching markets and other outlets that
Yep.
wouldn't necessarily be, you know, by commission. So just
Sure.
thinking about the economic forces that were influencing investment, access to trade, or distant markets really begins to introduce a whole different kind of economy than one that would be doing service work. So that's
Exactly. Yeah. The service mills, I mean, they have their roots really, even though the technology goes back to ancient times, they really have their roots in medieval Europe, with the lord of the manor having the rights to grist mills. I mean, in the Domesday Book, which William the Conqueror commissioned in England in the 1080s, for heaven's sakes,
Mhm.
there's like a grist mill for every couple of hundred English
Wow.
English men and women. It's
Great.
there's mills all over. But these are all basically selling a service to the neighborhood. Sometimes I equate them to uh to dry cleaners. You bring something in, you pay to have it processed because they can do it more efficiently than you can do it yourself, and you go back and you'll pick up exactly what you brought in, but it's been processed. The
Uh-huh.
exception to that are cider mills. Here in New England, cider mills tend to be more like a laundromat. You basically go in, you rent the machinery, but you do everything yourself, and
Oh,
then take back what you brought in.
there was a question from Art O'Day, who was interested in the bearings that were used in the shafts,
Sure.
and, that kind of material technology.
Yeah. Traditionally, you're using hardwoods, especially on the end grain, where it wears better. Sometimes they're using graphite to polish and give a harder bearing surface. Usually, you're lubricating them unless they're underwater. Water is a wonderful lubricant material, but if it's not suffused with water, usually you're using animal-based lubricants, animal fats, which break down fairly quickly and can be acidic and bad on bearings. Sometimes for heavy shafts, water wheel shafts, sometimes they're using polished stone. By the industrial era, you're sometimes introducing bronze, and for lower load bearings, not so much for water wheels, but for machinery. Sometimes you're using lead and tin alloys, what becomes called Babbitt metal. In fact, in I believe it's 1840s or 50s, there's a whole series. There's a law case in England over who has proprietary rights to these different lead tin alloys that are used, and there's different hardnesses depending on other alloying metals, including copper.
Mhm.
I believe there's 10 different hardnesses you can do in Babbitt metal. But these are basically for fairly low load, not great amount of weight or terribly high speed. But that's a common. They're also using bronze.
Mhm.
But for your water wheels and things like that, it's either wood, hardwood, or a polished stone. And sometimes iron. Iron is a good bearing material as well if it's well lubricated.
Pat Boyle-Steed asks a good question, and she's wondering about who were the mechanics who built the water wheels. What was
Yeah, that's a great question. These people, it's a trade, like dozens of other trades. It's called a millwright. The suffix "right" in English means to build, usually from wood, and like house rights and shipwrights and cartwrights and wheelwrights. A millwright is apprentice to the trade as a boy, studies with a master. You learn your hand skills, the woodworking and metalworking, and also the calculations of uh, figuring out gear ratios and the best materials to build your gear teeth from. Usually your gear teeth are smooth hardwoods like fruit wood because it tends to have an irregular grain. Um, or sometimes you could use rock maple. There's all sorts of things you don't want to use oak. Oak is a When oak trees grow, they absorb silica from the soil. So while oak is a hardwood, it also can be microscopically abrasive, so you don't want to use that for like gear teeth because they won't last as long as smoother hardwoods like pear, apple, rock maple, sugar maple, which is the same thing. As a tree, it's called sugar maple. As a wood, it's called rock maple. Like, when it's running around on four legs, it's a pig. When it's on your plate, it's pork. That kind of trick with English. Anyway,
One thing we'd like to explore is the tradition of machine building,
sure.
which is related to the mechanics and millwrights who built the mills. But like you, your carding machine, which is it a Schofield carding
Well,
machine?
it's a Schofield type. I mean, I don't think there's any Schofield machines anybody can document.
Okay.
They're called Schofield type. Arthur Schofield, when he went his own ways from his brother John, started making carding machines in Pittsfield, Massachusetts.
Oh, okay.
But I don't think anybody has documented a real Schofield machine that has his name on it.
For the people on
But
the
it's a
call.
type. It's a type. Schofields came over from England in the 1780s, 90s, and then Byfield, I think they were
Yep,
commissioned to
that's
make a
right.
carding
And the
machine.
Newburyport.
Yeah,
And
and
then
they tried making carding machines for other people. They made carding machines for themselves.
right.
Like I said, when John and Arthur went their own separate ways, Arthur manufactured and sold them. And
Okay.
there are no document that I've ever found Schofield machines,
Okay.
Schofield type
So,
machines.
so where I was going with the observation or the question was, that's an entirely wooden machine that has metal shafts that, turn the works. So when you think of mill machinery or industrial machinery, you often think of cast iron things, but there was a long period of time where the materials that were being used to make these things were wood. So it's a whole different kind of, technical system.
Yeah, I mean, with carding machines, the arches that hold the curves that hold the cylinders, the journals, the shafts of the cylinders are almost always iron.
Okay.
A number of different things, sometimes the struts, the spokes, if you will, of the cylinders, and even the rims of some of the cylinders, and some of even the pulleys are iron, even on some early machines.
Mhm.
Um, the problem with carding machines is they're very precise. I mean,
Yeah.
they need to be very, very precisely distanced. The
Right.
cylinders, except for the fancy, which has longer teeth, that's the only one that's supposed to touch another cylinder. They're all literally supposed to be thousandths of an
Yep.
inch apart, which is hard to maintain with wooden
Yeah.
components. And so they fairly early on go to cast iron,
Okay.
and then chilled cast iron because it's more stable for the arches of the machines. But yeah, they are using a lot of wood early on. The interesting thing to my mind is the number of not only British immigrants who are familiar with this technology that come here, but the number of Americans who either have seen something and say I can do it. In the early 18 teens, 1811 to 1813, here in Sturbridge, 12 different men got together and formed a company, not even a corporation, just a simple partnership to manufacture cotton.
Oh,
And part of the debacle, well, uh, Thomas Jefferson, of course, famously said America's workshop should be in Europe, and because he didn't have the economic sense that a kid with a lemonade stand has, his embargo of 1807 and then the Non-Intercourse Act of 1809 caused in the large part industrialization in the United States.
mhm.
And here in Sturbridge, not on our property, but a few miles downriver, in 1811, 12 men got together and to form a cotton manufacturing company. And one man just, said, I'll build the machines.
Mm.
He seems to have been born in Massachusetts.
Wow.
I don't know how he, learned it, but he did. And, he put together the machinery for this mill, carding machines and spinning frames and all the rest. I'm sure there's a lot of, independent invention and people just sort of tinkering,
Yep.
um, which I think was a real hallmark of the 19th century. I think it was a lot of something a lot of 19th century people, including Mark Twain really celebrated
Mhm.
that sort of American inventiveness and just sort of, tinkering around with things, trying to improve something you saw once, or I've got a better idea, I can do it better. So.
I think I'll take one more question, and we have it from Larry Pearl. And then what I'll suggest is, Meryl, after this question, you can end the recording, and then I'll linger, and we can have a conversation with any of our guests who want to stay. So Larry is one of our survey team members, and he asked this question: the evolution of the merchant mill, where the miller would sell his product, as compared to the service mill that you were talking about, where the farm. So how did, what were the forces that were at play that led to that whole thing of the merchant mill?
Well, I mean, usually when you say merchant mill, it refers to a flour mill, somebody who's manufacturing flour for sale. Usually that's more in the, you have it in New England, but it's more in the mid-Atlantic states where you have better grain land, and also where you're near the coast and have opportunity for export, for sending it off to market. So a lot of what happens with industrialization is you need to have what's now called infrastructure, better transportation routes, and more conducive economic climate, more currency, better currency, communication among markets that allows trade. So, your custom mill, your service mill, that's serving neighborhoods is fine, but you need to have raw materials and access to markets to have manufacturing make a go of it. So that's the short answer to that, to my mind.
I'm going to say right now, thank you to everybody who joined the call, our Zoom, our modern way of doing museum programs. Tom Kelleher, I want to say thanks to you. It was a treat meeting you.
Oh, my pleasure.